Hello friends, welcome back to Secret of Electronics. Have you ever wondered how 4-digit 7-segment displays actually work? In this video, I will show you a step-by-step tutorial how to easily interface a 4-digit 7-segment display with an Arduino Nano board. Trust me, by the end of this tutorial, you will be able to display numbers like a pro. Here we are using an Arduino Nano board to drive a 4-digit common cathode 7-segment display, which means each digit has its own common ground pin, while all the segment pins A to G and the decimal point are shared. The Arduino pins D2 to D9 are connected through 220 ohm resistors to the segment inputs A to G and DP. These resistors limit the current to protect both the display and the Arduino Nano board. The four common cathode pins of the display CC1 to CC4 are connected to pins D10, D11, D12 and D13 of the Arduino Nano board. This setup allows the Arduino to control each digit one at a time using a technique called multiplexing, lighting up one digit quickly after another so fast that our eyes see all four digits glowing together. This Arduino code derives a 4-digit common cathode 7-segment display with an Arduino Nano board. It shows a repeating sequence from 0000 to 9999, so all digits show the same number, updates the shown number every 1 second, and makes the decimal point blink every 1 second, all while using multiplexing, so the display looks steady with only a few Arduino pins. Seg pins array connects each segment pin A to G and DP to Arduino pins D2 to D9. Digit pins array selects which of the four digits is active. Because this is a common cathode display, setting a digit pin low turns that digit on. Next, the numbers array table. Each byte is a bit pattern that turns segments on or off for digits 0 to 9. The command tells you the bit ordering: bit 0 segment A, bit 1 segment B, bit 6 segment G, and bit 7 is the DP decimal point. In show digit, the code reads each bit and writes it to the corresponding segpins I array. Instance of delay, which freezes everything. This Arduino code uses millis to check elapsed time and update two independent timers, one to change the displayed number every 1 second, another to toggle the decimal point every 1 second. This keeps the UI responsive and makes the multiplexing smooth. Current num cycles 0 to 9, 9 to 0. When we went to display 0000, 1111, etc. we pass current num multiply by 1111 to display number. That's a neat trick. 3 multiply by 1111 equal 3333, etc. Core idea: light one digit at a time very fast, so your eyes merge them into a single stable display. Inside display number, split num into 4 digits. For each digit, call show digit to put segment pattern on the segment pins. Active the corresponding digit pin low. Wait a tiny delay 3 so the digit is visible. Then clear digits to turn that digit off and move the next. That delay 3 is short, fast enough to cycle through all 4 digits many times per second. Persistence of vision gives the appearance of steady illumination. Seg pattern comes from numbers num. If we want DP blinking on, B or in B1 7 times 0, so bit 7 equal 1. B iterate through bits 0 to 7 and set the segment pins accordingly. Finally, B set the chosen digit pin low to light that digit. Clear digits just sets all digit pins high so no digit is active. This avoids ghosting between digits when changing segment lines. Now let's upload the code to our Arduino Nano board. First, connect your Arduino Nano to your PC or laptop using a USB cable. Once it's connected, open the Arduino IDE. Now open the code file. You can download it from the link given in the description below. After opening the code, make sure you have selected the correct board and COM port under the Tools menu. Once everything is set, just hit that upload button and in a few seconds, your Arduino Nano will come to life and start running the code. Pretty simple, right? Now it is time to connect all the components, just like we saw in the main circuit diagram at the beginning of this tutorial. Make sure you double check each connection before powering it up. Now connect the Arduino Nano board to a 5V power supply using a USB cable or a 5V DC adapter. After connecting, you will see the numbers appear on the 4-digit 7-segment display. If you liked this tutorial, then do not forget to subscribe to our YouTube channel for more upcoming and interesting tutorials. And if you want me to make a project using a 4-digit 7-segment display, just let me know in the comment section. I will be happy to create it.